So we got y equals f of x. We're supposed to draw y equals f of 3 times x. So if you multiply x by like something between 0 and 1, like 1/2, that means it stretches out the graph. It takes double the time to reach these points. So this would be the graph of 1, 2. This would be the graph of y equals 1/2 of x. And that's just a quick rough sketch. Makes it take longer. Now if you multiply x by something that is greater than 1, then it's speeding everything up that's happening in the function. So f of 3x, that means I should be getting to the first point, 1, 1, in 1/3 the time, right? Because we're doing things 3 times as fast. So that's within 1/3, so 0 to 1, that's 1/3 distance on this new graph because it's times 3. From 1 to 2, that's also another third, so this looks to be a third. The y-coordinates still stay the same. And then from 2 to 3, that's another third, so that puts us at a whole 1. We're back down to 0. Okay, let me see if I can get another one of those. I know those ones are tricky. Graph functions using compressions and stretches. So we got the graph of y equals f of x in blue. We're supposed to draw the red graph when it's the graph when y equals 1/2 times f of x. So this basically means we're shrinking the graph because we're multiplying every y coordinate by 1/2. So take this first one, it's at 0, 0. The only thing that's changing, the x coordinates, when you plug in x equals 0 into this function, the y coordinates are going to be 1/2 what the old y coordinates used to be. So this is still going to be 0. Because 1/2 times 0 makes 0. It'll make more sense probably with the next point here. This next point is at 1, 4. So our transformation function is 1/2 times that y coordinate. So we're going to be down to 2 here. And then for this next point here, this is at this is 2, 0. So if you multiply 1/2 to 0 to the y coordinate, it brings us back down to 0. So that's our transformation. Let's see if we can get another. This is different.